Hi, my fellow intellectual. So today we are looking at this is linear, no, this is relative motion. Yeah, we're looking at relative motion that is under kinematics. So this is by excellence tutorials. And yeah, if you need a tutor to tutor you in physics or in mathematics online, you can arrange with me and get in touch with me on the number that is dropped in the description box. And if you have not subscribed yet to the channel, kindly do so, and make sure you also hit the notification bell so that you get notified each time I upload a new video. Okay, so we are dealing with this question now that is about relative motion. So as two boats approach the Marina, the velocity of boat 1 relative to boat 2 is 2.15 meter per second in the direction 45 degrees east of north. If boat 1 has a velocity that is 0.775 meter per second due north, what is the velocity, meaning the magnitude and direction of boat 2? So I would say in this scenario, we have this kind of scenario. Okay, so we have our compass. This is our compass. So we have north, east, west, and south. Okay, so we've been taught to say the velocity relative, okay, boat 1 to boat 2 is, so boat 1 to 2, 45 degrees, no, 47, sorry, 47 degrees, okay, east of north. So that's where the angle is. And then we also have, let me use this. We also have that, okay, we also have that, and that is for boat 1. The velocity is, so velocity for boat 1 is 0.775 meter due north. Okay, so now we want the velocity for boat 2. So how do we calculate that? So the first thing that we have to do is to resolve the relative velocity of boat 1 to boat 2, resolve it according to their direction. So we are going to have, in our x, we are going to have in the horizontal 2.15 sine 47, and then in the y, we are going to have 2.15 cos 47. So we can write that. So we have V1/2. We have 2.15 sine 45. No, 47. Why do I keep on saying 45? Okay, so this is in the horizontal. We can put also our unit direction, and then plus we have 2.15 cos 47. This is the J. So we can punch that one, and then we get 2.5. So we get 1.57 I, then 2.15 cos 47. So we get plus 1.47 J. So that this is our relative velocity in component form. Okay, so now we can also write the velocity for both one also in component form, and for both one we've been taught to say its velocity is just in the y, so we have 775 j. Okay, so the angle there is 90 degrees. So if we do cos 90, you get 0, and sin 90, you get 1. So we end up having that one. So for velocity for 2, we're going to have v2x I plus v2yj. Okay, so those are going to be components. So now we need to find these components. So now, according to relative motion there, we have the relative motion of 1 to 2 is given by the velocity of 1 minus the velocity of the both 2. Okay, so we have 1.57 I plus 1.47 j. That is for that's the relative velocity, and one we have 0 in the I plus 0.775 j minus v2x plus v2yj. Okay, so okay, we can only add or subtract if they have same unit direction. So what is here, we are going to have 0 plus minus that, we get negative 2x I, and then also we have plus 0.775 minus v2yj, and this equal to that. So that's for j. So we can equate those with the unit vectors I and those with unit vectors j respectively. So we have 1.75 I being equal to negative v2xi. So that and that goes, and then we have v2x equal to negative 1.7. Okay, so we found the x component of speed for both 2, and then for the other side we have 1.47 j being equal to 0.775 minus v2y j. So the j goes, and then the 0.77 comes this other side, and what we are going to have is it's going to be a minus. So it's going to be a subtraction. So it's going to be 1.47 minus 0.775. Okay, so we get 0.6. Okay, so now remember that the v2y has got a negative in front, so it's going to go to the other side as well, so that v2y is equal to negative 0.695. Okay, so of course these are in meters per second. So these are the components. So from the components now we can be able to calculate the magnitude. So our magnitude, we know v2, finding magnitude is v2x squared plus v2y squared, so that we have negative 1.57 squared plus negative 0.695 squared. So V2 is going to be here is a point 1.57. Going to have 2.465 plus that. Square root of that, we get V2 being equal to 1.72 meters per second. So this is going to be the magnitude for the velocity. Okay, 1.72 meters per second. Okay, so now we can be able to calculate the direction as well, which we know that for direction we have so that there is tan inverse of negative 0.695 over 1.5, negative of course, 7. Okay, so we have so the angle is 23.9 degrees. Okay, so where is this angle? 23.9 degrees. So we can see that they're both components. I just want to help you to locate this angle. So both components of the velocity for both two are in the negative or have the negative or in the negative direction. So the x is negative, the y is negative, and the quadrant in which we have such is this quadrant, the third quadrant. So we have both two moving in that direction, 23.9 degrees, and that is south of west. Okay, so it's moving at a speed of 1.72 meters, 23.9 degrees south of west. Thank you so much for watching and hope to see you in the next video. Make sure you invite others and share with others also.